Hello, my name is Kayla. Today I'll be talking to you about covalent bonds. To get to covalent bonds, we need to answer a question. Why would atoms ever want to stick together? The answer is to achieve an octet, to gain an outer S2p6 configuration. An octet. So that's 8 electrons, an octet, on the outer shell of the valence electrons. So anytime an atom can lose, gain, or share electrons in order to get that octet, then you will have a chemical bond. The octet rule. The octet rule requires all atoms in a molecule to have 8 electrons, either by sharing, losing, or gaining electrons to become stable. There are 2 exceptions. Hydrogen and helium want 2 instead of 8. So the number of valence electrons and the number of bonds is always going to equal 8 for everything except hydrogen and helium. Valence electrons are the outermost electrons used to form a bond to another atom. How many valence electrons in an atom? First, you find an atom on the periodic table. Second, find the column number. Third, the column number is the number of valence electrons. What are covalent bonds? In covalent bonds, atoms still want to achieve a noble gas configuration, the octet rule. But rather than losing or gaining electrons, atoms achieve an octet by sharing electrons. We can predict the total number of electrons in an atom by looking at the periodic table. So for example, Br2. If we look at the periodic table, bromine is in column 17 on the periodic table. Therefore, it has a total of 7 valence electrons. 7. What is a single bond? A single bond is a single pair of electrons shared. What is a double bond? A double bond is a bond in which 2 pairs of electrons are shared between 2 atoms. Step by step. First, count the total valence electrons. Second, arrange atoms with generally the least electronegativities in the center. Third, give each atom a full valence shell. Fourth, the total number of dots should equal the valence electrons. Chlorine is one of the diatomic molecules that can form a covalent bond with itself. If we look at each structure, they both have 7 valence electrons. They each want to gain 1 electron, but they are both highly electronegative. Neither one will give up an electron they both want to gain. The solution is that they can share their electrons. So now, each chlorine, if they count the electrons that are being shared, they will have an octet. And the electrons in the middle are the bonding pair. In the middle are the bonding pair. So that pair is shared and it is called a single bond. So this is called covalent bonding. Co, together, valent, valence electrons. The sharing of electrons to achieve an octet, a stable noble gas configuration. Next, I'll talk about the rate of a chemical reaction and how a catalyst can affect the rate of a chemical reaction. So first, you need to know that in a chemical reaction, the matter changes to a different kind of matter or change in color. A catalyst is a substance that increases the rate of a chemical reaction without being changed by the reaction. Catalysts in living organisms are called enzymes. This graph shows that a positive catalyst increases the rate of a reaction by lowering the activation energy. The rate of a reaction depends on the activation energy necessary to initiate it. Catalysts reduce the activation energy and increase the rate of reaction, although they do not change the final proportion of the reactants and products. The green shows a catalyzed reaction, the black shows an uncatalyzed reaction, and the red X's show the activation energy. Next, I will demonstrate an experiment called the paperclip catalyst. So what you need for this experiment is a dollar bill or paper shaped the size of a dollar bill and 2 large paper clips. The paper strip represents the enzymes and the paper clip represents the 2 chemicals. First, fold your paper into thirds, like this. Then put the first paper clip in the first 2 folds closest to you, like this. Then put the second paper in the other 2 folds farthest from you. Your paper should look like this. Then grab the 2 ends of the dollar bill and pull. Your paper clips should be linked together. This shows that a catalyst speeds up the reaction but does not become a part of the reaction. The movement of the paper results in the paper clips should be joined. The folded paper represents a catalyst, which increases the possibility that 2 chemicals, the paper clips, will combine. The combined paper clips represent a new chemical product. The catalyst is actively involved in the chemical combination, the connection of the paper clips. But the catalyst, the paper, is not a reactant or part of the product. The catalyst can be used over and over again. That concludes my lesson for covalent bonding and the paperclip catalyst experiment. Hope you enjoyed watching and hope you learned a little something new. Thanks, bye.